In this video, I'm going to go over imine formation. So with just like all ketone-based reactions, we're going to be do this in the presence of acid. And in this case, our nucleophile is going to be a primary amine. So that primary amine is going to attack the carbonyl, and then eventually, through a series of acid-base steps, lead us to imine formation. So the three things you have to remember for a reaction like this is our nucleophile is the amine and our electrophile is the carbonyl. Then the second thing to know is that these reaction mechanisms have a lot of acid-base steps, so a lot of proton transfers. And then it looks like a long mechanism, but you can split it into two parts. In the first part, you go from your starting molecule to your neutral intermediate. Then in the second part, you go from your neutral intermediate to your final product. So let's start. We have our weak nucleophile and then moderate electrophile. So we can make this react by activating the carbonyl, and that'll happen through a protonation step right here. So that lone pair on the oxygen will take that hydrogen, and then the bond will go back to the oxygen as a lone pair. Now that we've activated our carbonyl, it's much more reactive, and now that methylamine can attack it. So the lone pair on the nitrogen will attack that carbon, and then it'll kick up this pi bond upwards. Now we have this intermediate, and the plus charge is on the nitrogen. So in order to make it a neutral intermediate, we're going to have to deprotonate this nitrogen. And that can happen with this water taking this hydrogen and doing that. So as you can see, there's a lot of just proton transfers. And now you have your neutral intermediate. So from here, you're going to work towards your final product. And that's going to happen through getting rid of your unwanted functional group. In this case, our unwanted functional group is OH. And since OH is a bad leaving group, we're going to protonate it to make it a good leaving group. So the lone pair on this oxygen is going to take that hydrogen, and then the bond is going to go back to that as a lone pair. And now you have your good leaving group. So this lone pair on the nitrogen can go down and kick it out. Now you're almost at your final product. Now that your nitrogen has a +1 formal charge, you have to deprotonate that. And so that water that just left can just pick up that hydrogen, and now you have your final product.